Welcome to Secrets of Antiquity, where we delve deep into the ancient mysteries and uncover truths about the history of our planet that remain hidden from the common eye. Today, we are embarking on a journey to explore one of the most enigmatic phenomena in geology, the Great Unconformity, a vast gap in the Earth's geological history, where we have lost nearly 1 billion years of time. This isn't just a blank space in the rock layers, but a profound mystery that continues to baffle scientists and researchers across the globe. Imagine, for a moment, that the story of Earth is like a grand book. Every layer of rock, every fossil embedded in its strata tells a story, a chapter of time. But within this great narrative, there exists an inexplicable void, a missing chapter, a gap so wide that it spans the length of an entire billion years. How could this have happened? How could an entire epoch, one that likely shaped life on this planet, simply disappear? In the world of geology, the Great Unconformity stands as an unsolved riddle, a question mark hanging over the long, complex history of Earth. No one truly knows what happened during those lost years, nor why we have no record of it. Some speculate that a cataclysmic event erased it all. Others suggest that this gap might have been a result of Earth's shifting landscapes, or even a sign of a far deeper, universal mystery. But the truth is, we simply do not know. What we do know is that it's a clue, one that beckons us to look deeper, to ask questions, to dig further into the Earth's layers, hoping that one day we might find an answer. And so, today, we embark on this quest to understand the Great Unconformity, and with it, the secrets it may hold about the very origins of life and the Earth itself. To truly understand the Great Unconformity, we must first delve into the process by which rock layers are formed, for it is these very layers that hold the key to unlocking Earth's ancient history. As we dig deeper into the Earth's crust, we uncover ancient layers of rock, each one a record of a time long past, holding within it the stories of life and the environment as it once was. The formation of these layers begins with something as simple, yet as profound, as dust and sand. Over millions of years, fine particles carried by wind, water, and even volcanic activity settle onto the surface of the Earth, gathering in layers, each one distinct. This process is called deposition, a slow and steady accumulation that occurs over eons. Imagine, if you will, the Earth as a vast canvas, and each layer of sediment is a stroke of nature's brush, painting the history of the planet. But deposition is only the first step. These particles don't just sit there. Over time, they become compacted and cemented together through a process known as cementation. This is where the magic happens. The individual grains of sand, dust, and minerals bind together, creating a solid rock. It's as if the Earth, in its infinite wisdom, decides that these particles should not merely rest on its surface, but should endure, preserved through time as a permanent record of what came before. Within these layers, fossils are often formed. Fossils are the preserved remains or traces of ancient life, plants, animals, and microorganisms that once walked, swam, or flew across the Earth. As creatures lived and died, their bodies would become entombed in the accumulating sediments. While the soft parts of their bodies decomposed or were eaten away, their harder parts, bones, shells, teeth were often preserved, encased in layers of sedimentary rock. This process, called fossilization, is a rare and precious occurrence. Over millions of years, minerals slowly seep into the remains of the creature, filling the void left by decaying organic matter. Eventually, the creature's remains are replaced by minerals, transforming into a fossil, an exact, albeit stone, replica of the original organism. This transformation, this capturing of life in rock, provides us with a window into the distant past. The significance of these rock layers cannot be overstated. Each layer tells a story. Each fossil embedded within it adds a chapter to the Earth's history. They allow us to peer into the distant past and understand the development of life across countless ages. As geologists, We use these layers to read the Earth's biography, piecing together the puzzle of time, one layer at a time. But what happens when that story is interrupted? What happens when a gap appears, when a chapter is lost? This is where the Great Unconformity becomes all the more intriguing. You see, these rock layers are generally predictable. When we look at a cross-section of rock, we can follow the law of superposition, which tells us that the deeper we go, the older the rock. But when we encounter the Great Unconformity, we find something startling, a missing chapter, a billion years of Earth's history, lost to time, and we don't know where it went. As we continue our journey through Earth's ancient history, we find ourselves standing before an enigma so perplexing that it challenges our very understanding of time and the planet's past. This is the phenomenon known as the Great Unconformity, and it represents one of the most significant gaps in the geological record, a mysterious void that stretches across time, leaving us with a loss of over a billion years of Earth's history. Now, to understand this, let us first examine what we know about geological layers. As I mentioned earlier, the process of rock formation is usually quite orderly. Over time, sediments accumulate, forming distinct layers that record the passage of time. These layers contain fossils, remnants of past life, and geological features that tell the story of the planet. Each layer serves as a chapter in the Earth story, laid one atop the other, preserving a history that dates back millions, even billions, of years. But then, something extraordinary happens. While we often expect a smooth, continuous progression of layers as we dig deeper, in certain regions, this expectation is shattered. The layers suddenly stop, and in their place, there is a noticeable gap. This is where the mystery begins. The gap is not just a small interruption. It is a massive break in the timeline of Earth's history, where hundreds of millions, or even a billion years, appear to be missing. This phenomenon, as it is known in geology, is called an unconformity. It is a situation where layers of rock that should have formed over time, building upon one another, are instead separated by a void, an absence that defies conventional understanding. The Great Unconformity specifically refers to one of the most dramatic examples of this, where the rock layers in some places on Earth are so disconnected from the layers above them that they appear as though they belong to entirely different timelines. To truly appreciate the significance of this, let's think about it in terms of the Earth's biography. Imagine a book where entire chapters are missing. The book may still be readable, but those missing chapters hold crucial information, secrets that could change everything we know about the narrative. This is precisely what the Great Unconformity represents. It is not just a gap in the rock, it is a gap in the Earth story, a void where history has been lost, and we are left to wonder why. Now, the first question that naturally arises is, how did this happen? How could such a large portion of Earth's history simply vanish? There are a number of theories, each one attempting to explain this great mystery. Some scientists propose that erosion may have played a role, suggesting that forces of nature could have stripped away the rock layers, leaving behind nothing but bare Earth. Others believe that tectonic movements might have caused these layers to shift or fold, obscuring the evidence of the lost years. But there's an even deeper layer to this mystery, an unsettling possibility. Could the missing chapters of Earth's history have been wiped away by catastrophic events? Could great cosmic collisions, or even a series of planetary upheavals, have erased the traces of entire epochs? These are questions that continue to intrigue scientists and historians alike, as they probe deeper into the geological mysteries of the Great Unconformity. In some regions, the gap between the missing layers is so vast that it spans entire geological eras. The Great Unconformity is not merely a gap in our geological knowledge. It's a reminder that there are still deep, uncharted mysteries beneath the surface of the Earth. Perhaps, just perhaps, we are standing at the edge of an ancient puzzle that has yet to be solved, waiting for us to unlock the secrets hidden within these vast, empty spaces. As we move further into the mysteries of Earth's geological past, One of the most fascinating theories about the disappearance of so much of its history is the Snowball Earth hypothesis. To understand how it fits into the puzzle of the Great Unconformity, we need to transport ourselves back about 650 million years to a time when Earth was drastically different from the world we know today. Imagine, if you will, a world where ice covered the entire planet, every ocean, every continent, even the equator itself. This was not a temporary ice age but a global phenomenon, where temperatures plummeted so drastically that Earth became a giant snowball. The Snowball Earth hypothesis suggests that our planet underwent a freeze so severe that it encapsulated the entire surface in ice, a state that lasted for millions of years. Why is this so important for understanding the Great Unconformity? Well, this extreme ice age could explain why so much geological history has been erased. The immense glaciers that would have stretched across the continents, moving across the land like slow-moving bulldozers, could have scraped away entire layers of rock. As the glaciers advanced, they would have ground down the older rocks, eroding them away and potentially destroying entire layers that contained fossils and the traces of ancient life. In essence, the powerful ice sheets could have wiped the slate clean, erasing large chunks of Earth's geological record. In this frozen world, not only did the physical rocks disappear, but the process of life itself was severely impacted. Life on Earth would have been drastically slowed, if not entirely halted, by the extreme cold. Photosynthesis, the process that sustains much of life on Earth, would have been virtually impossible. The Earth's oceans would have been frozen, and most land would have been uninhabitable. For millions of years, the planet was a barren wasteland until the ice finally began to recede. Now, this theory is more than just a fascinating thought experiment. It has strong scientific backing. Geologists have found evidence of ancient glacial deposits in places that should not have seen ice. Like the tropics, this evidence suggests that Earth's surface was once entirely covered in ice, a state that would have been almost impossible to survive in for any form of life. The idea that such a catastrophe could have wiped out so much of the Earth's geological record helps to explain the Great Unconformity. If glaciers were scraping away rock and wiping out life, it would make sense that large gaps in the geological timeline could have formed. The layers that were once here, recording millions of years of Earth's history, could have been lost in the ice sheet's advance, leaving us with a massive hole in the geological record. This theory also highlights the delicate balance of life on Earth. The Snowball Earth hypothesis suggests that life as we know it could have very easily been destroyed in this frozen cataclysm. It is only thanks to the resilience of life and the eventual warming of the Earth that we see the diversity of life that exists today. The missing records, the absence of evidence from those lost years, serve as a stark reminder of how fragile our planet and its history truly is. As we continue our exploration of the Great Unconformity, one cannot help but be struck by the remarkable discoveries scattered across the Earth, each offering us a glimpse into the vast, mysterious gaps in our planet's geological history. The concept of an unconformity, a gap in the rock layers, takes on new life when we witness it firsthand in some of the world's most iconic geological sites. It's here, in these ancient rock formations, where we encounter a history not just lost, but nearly erased from time itself. One of the most prominent examples of the Great Unconformity is found in the Grand Canyon, one of the planet's most recognizable natural landmarks. Standing on the edge of this magnificent chasm, it's hard to ignore the layers of rock that tell the story of Earth's past. However, there is a striking anomaly. Beneath the canyon's top layers, we find a series of ancient rocks, some dating back a staggering 1.7 billion years. These rocks lie directly under much younger formations that are only around 525 million years old. This gap between the layers is nothing short of mind-boggling. More than 1 billion years of Earth's history appear to have simply vanished. No trace of life, no record of geological events from that time, just a vast empty space in the rock record. This is what scientists have come to call the Great Unconformity, and it remains one of the most perplexing puzzles in the study of Earth's history. How did this enormous gap form? Why is there such a large, unaccounted for stretch of time in the geological record? These questions have sparked centuries of debate among geologists. Yet the answers remain elusive. In addition to the Grand Canyon, there are other sites around the world that reveal similar mysteries. Take the Ozark Plateau in Missouri. For example, here, we see yet another perplexing anomaly in the rock layers. The oldest rock layers found in the Ozarks are granite, formed 1.4 billion years ago, yet resting on top of this ancient granite is a layer of sandstone, which is a relatively young 500 million years old. The juxtaposition of these two layers, one so ancient and the other so young, raises the same fundamental question that we saw in the Grand Canyon. How could such a vast span of time be missing from the geological record? What's fascinating about these findings is not just the mystery they present, but the profound implications they have for our understanding of Earth's history. These gaps are not simply small anomalies. They represent vast, nearly unimaginable stretches of time, periods when life, climate, and the very landscape of the Earth were in a state of flux. But because so much of the rock record has been lost, it's as though we are trying to read a book with many of its pages torn out. The lost chapters could contain answers to questions we haven't even thought to ask yet. So, what could explain these anomalies? The Great Unconformity might be the result of some of the most extreme events in Earth's geological history, such as glaciation, tectonic activity, or massive erosion. Each of these processes could have contributed to the loss of millions, if not billions, of years from the Earth's history. And as we search for answers in these sites of great mystery, we are reminded of the fragility of the Earth's geological record and the potential for secrets that are still waiting to be uncovered. As we stand on the precipice of ancient knowledge, we are faced with questions that seem as vast and elusive as the gaps in the rock layers themselves. The mystery of the Great Unconformity, the missing chapters of Earth's history, has puzzled geologists and scientists for generations. Yet, despite the immense challenges in solving this enigma, it is this very mystery that drives us forward in our quest for understanding. It is within the pursuit of such questions that the true significance of our studies lies. The importance of investigating the Great Unconformity cannot be overstated. We may not have all the answers today, but every step forward in our understanding opens up new pathways for discovery. Each new insight, whether a tiny shard of evidence or a groundbreaking theory, brings us closer to unraveling the secrets that lie hidden beneath the Earth's surface. For it is not just the gap in the geological record that is significant, but what it reveals about our planet's dynamic nature and its ability to both preserve and erase its history. At its core, this mystery reminds us of the fragility of the Earth's geological record. Rocks, the oldest archives of Earth's past, have often been buried or destroyed by natural forces. Wind, water, glaciers, and even tectonic shifts have altered and reshaped the Earth's surface in ways that make it difficult to piece together a coherent history. But as our tools and technologies improve, as we develop more sophisticated methods of dating, analyzing, and observing, we inch ever closer to discovering the hidden truths beneath the surface. This exploration is not just about uncovering missing rocks or lost time. It is about understanding the forces that have shaped life on this planet, the very same forces that continue to shape our future. The Great Unconformity may hold answers to some of the most fundamental questions about Earth's past. How did life begin? What were the conditions that allowed life to evolve? What catastrophic events might have led to the gaps we see today? These questions extend far beyond the realm of geology. They touch upon the heart of our existence. As we search for answers, we are also searching for our own place in the grand story of life on Earth. For every discovery made, we not only come closer to understanding the past, but also gain insight into the forces that continue to shape the world around us. We begin to realize that Earth's history is not merely a series of random events, but rather a complex, interwoven tale, a story that still continues to unfold before our very eyes. Moreover, the study of the Great Unconformity holds profound implications for how we view the passage of time and the nature of change itself. In many ways, the very existence of these massive gaps in the rock record forces us to confront the impermanence of all things. The Earth has undergone tremendous transformations, and much of its history has been lost to time. But this loss is not an end. It is a beginning. Each discovery we make, each theory we test, adds to the grand mosaic of knowledge that will, one day, fill in the gaps and illuminate the path forward. The quest for answers is a journey, and while we may never completely unravel the full mystery of the Great Unconformity, it is the pursuit itself that enriches our understanding of the Earth and our place within it. It is through this very search for the unknown that we unlock new truths about our planet, our history, and our future, as we draw our journey through the mystery of the Great Unconformity to a close. We are left with more questions than answers, questions that, perhaps, will never fully be answered. And yet, it is precisely in this uncertainty that the true wonder lies. The gaps in Earth's geological record are not mere absences. They are profound markers of transformation. They remind us that the Earth is not a static, unchanging entity, but a living, breathing planet constantly evolving. The absence of time, encapsulated in these missing layers of rock, tells the story of forces at work, forces beyond our comprehension, yet intricately shaping the very fabric of our existence. What we have learned today is not just about rocks, or missing time, or even the deep mysteries buried beneath the surface of the Earth. Rather, we have come to understand that the Earth, in all its complexity, is a mirror of our own journey, an ongoing process of change and adaptation. The geological history that we seek to uncover is a reflection of the forces of nature, the forces of life, and even the forces of the mind. The more we learn about the Earth's history, the more we come to understand our own place within this vast, interconnected web of existence. Perhaps the most profound lesson from studying the Great Unconformity is not that we must understand every gap in the geological record. Rather, it is that we are forever bound by the mysteries that remain. These gaps challenge us, push us to seek more knowledge, and remind us that we are part of something far greater than ourselves. In our quest for understanding, we are not just uncovering the history of the Earth, we are discovering the story of life itself. And while we may never fully explain every aspect of this ancient puzzle, our journey is what matters most. Each discovery we make adds another piece to the grand tapestry of knowledge, helping us understand our world and ourselves more deeply. So, we continue to explore, to question, to learn, because the mysteries of the past are not just relics of history, they are the keys to unlocking the future. Thank you for joining me on this journey of discovery today. If you found this video intriguing, be sure to hit the like button, subscribe to the channel, and turn on notifications so you never miss an episode. Together, let's continue exploring the mysteries of the ancient world, uncovering the secrets that still lie hidden in the depths of time. Until next time, stay curious, stay inspired, and keep seeking the wonders of the universe.